In this video, this algebra topic video, we'll look at one of these fun problems that late night comedians always like to make fun of, this distance equals rate times time. Here's the problem. A jogger begins her workout by jogging to the park, a distance of 7 miles. Then she jogs home at the same speed, but along a different route. This return trip is 14 miles and her time is 1 hour longer. Find her jogging speed. Complete the accompanying chart and use it to find her jogging speed. Let x equal the jogging speed. Here's a chart we can use, and I've filled in some of the numbers already. Let me highlight as we discuss those so you can see what's going on here. She begins her workout by jogging to the park, a distance of 7 miles. So to the park, distance, 7 miles. Then she jogs home at the same speed. And we've got that let x equal the jogging speed. So the rate for this distance equals rate times time. And by the way, that is one of those formulas you do need to commit to memory. This is useful for a number of things, even in average, everyday life when you're driving somewhere. You're trying to calculate how long is it going to take me. You can use this distance equals rate times time. And then when she comes back at the same speed, she uses a different route. So the return trip is 14 miles. So the distance of the return trip is 14. Her time is 1 hour longer coming home. So her time home is 1 hour longer. Let's see what we can do with this. To start with, we're going to use this formula that you need to commit to memory, this distance equals rate times time. And we're going to say if distance equals rate times time, then I can solve for time by dividing both sides by rate. So if I divide by rate, then I'd get that time is distance over rate. And I could do the same thing to solve for rate. If we have distance equals rate times time, and I divide both sides by the time, then I get that the rate is distance divided by t. So you could see how either of these formulas can be derived by dividing distance. So it's distance divided by rate, or distance divided by time gives us the rate or the time. Using that, we could calculate that time is this distance 7 divided by rate x, or this distance 14 divided by the rate x. So I could fill in the chart with these times. Now let's use the next piece of information, a separate piece of information. They just slide it in, and this is where you have to start by reading really carefully. Where was it? Her time jogging home is 1 hour longer. The return trip is 14 miles and our time is 1 hour longer. So if the time home is 1 hour longer, we can imagine that this time home is heavier, right? If time was something we could measure in weight, the time home is heavier. If we wanted to balance this out, we'd have to add 1 hour to our time to the park to make them equal. We'd have to add 1 hour to the smaller amount to make them equal. Or what if we did this? Since this one's heavier, subtract a pound off, or an hour off in time, and now they're going to be equal. Either way will work. I tend to like working with addition, so I'm going to add the 1 over here. Now what you don't want to do is both. Do either or. Either add 1 to the lesser amount, the time running to the park, or subtract 1 from the greater amount, and they'd be equal. Here's another way to see that. Think of it as a linear amount. The time to the park is this blue line. The time back home is equivalent to the blue line plus 1 more. So if we wanted to make them equal, we'd have to take the time to the park, the 7 over x, and we'd have to add 1 to it to get it to be equal to the time coming back home, the 14 over x. But one way or another, this is the equation we're going for, and the next step is going to be to solve that equation. So let's look at how to solve that equation. I'm going to solve it 2 different ways. We could solve it by getting the common denominator all the way across. So the common denominator is going to be x. So that would mean simply multiplying the 1 times x. And once we have a common denominator all the way across, we can actually eliminate these denominators. And if you're not sure about that, watch the previous video I have for solving the equations that are rational, and it explains why that works. But we'd have 7 plus 1x equals 14. Look how easy it is from there, because now it's just subtract 7, and we've got x equals 7. That's one way to solve the equation. And what we're doing is saying that if this fraction, the numerator over an x plus another numerator over x, if that's equal to 14 over x, then the sum of the 2 numerators is going to be equal to this other numerator. And for this other method, what we're going to do is simply multiply everything by the common denominator x. So we get the either way, we need to get that least common denominator is x. So either method starts with finding that the least common denominator for 7 over x, 1, and 14 over x is x. But with this method, we'll multiply everything through by the common denominator. The way I'm going to show that, and you can see how I've left some space here for the 7 over x, the way I'm going to show that is with another colored pen. So I'm using this green. I'm writing in that x to each of the pieces. It goes to the numerator, by the way, because it's an x over 1 that we're multiplying. So we multiply 7 times x in the denominator times 1. 1 times x is just x, and then 14 times x over x times 1. When we've done that, the next step is we're ready to reduce. So do you see what reduces? This x over x divides out, and this x over x divides out. And what we're left with, it's the same thing we're left with over on the left. The x is divided out, so we've got 7 plus 1 times x equals, these x's divided out, equals 14, and then solve for x. So I'll subtract 7 from both sides, and I have x equals 7. Either way, we got the x equals 7. So let's go back to the problem and make sure we've answered it. Find her jogging speed. We found that common jogging speed was 7, so we could say, therefore, her jogging speed is 7 what? Miles per hour, right? Because we were measuring in miles. And we're going to use the time in hours. 7 miles per hour. And that wraps up this example. I hope that clarifies any question you had about this problem. If you do have other questions, I'd encourage you to rewind the video, watch it again, or send me a question if you have a specific question about the example. And thanks for the work you're doing to learn these concepts. They're not all easy, But with practice, they really do get easier and easier, and I know you can do this.